Okay, so hello everyone, welcome to my video. So this is the third part and the last part in the series of auto threshold project. So let's quickly summarize what is being done and what is being left. As you can see in presentation window under highlights, auto thresholds for single or multiple auto threshold using mean, median, mode, standard deviation, quantile. I have shown that shallow test score has been left. So we will see the auto threshold use cases for clustering reports made via shallow test score. So the use of shallow test score in the scenario of designing the clusters. I mean, we will use the shallow test score to define how many clusters can be formed, and the cluster generation is being customized in this project. Also, as I told you last time, the role of AI agents is being added to this auto threshold project. So let's quickly check the next slide. Okay, yeah. So this is a fraud alert workflow. You can see here the data input data is coming and pre-processing and feature engineering steps are being taken. Then auto threshold will take place, and then rule-based anomaly alerts or AI agent-based for alerts will be generated. So I will tell you now. So rule-based anomaly alerts for data. So these are data anomalies. You can say that when data is not normal or abnormal. You can see here in example threshold. You can see in the presentation window. I have taken only two scenarios for data anomaly because I want to give a simple representation so that every technical and non-technical audience will understand. So what happens is, first example is high duration, that is more than 1000 minutes call. So as you can see that, as you can understand that, more than 1000 calls is something 16 hour something call that is highly suspicious, means not normal, or you can say abnormal, or we can say data anomaly. Secondly, the call is over. Second scenario is for overlap calls, means one call has not ended, another call started. So these are two scenarios, and we will use higher probabilities, greater than 90%. Yeah, as you can see here, example threshold. So yeah, so for what happens, that AI agent live training will be shown to you, and the actions taken by the AI agent live will be also uh, be shown in the alert generation. Okay, let's move to next slide. And the functionality and action of the AI agents will also be shown to you. So yeah, so these are, I told you, these only two scenarios are there: greater than 1000 minutes for single call, and overlap call for a single caller. Let's move to next slide. Okay. So this is the hybrid approach, as I told you, rule based anomaly alerts, and AI based AI agents. Okay. So this approach, how it works, I will just quickly summarize that. Rule based anomaly alerts will detect clear and predefined fraud cases, because we are giving extreme conditions, as I told you. Greater than 1000 minutes mean 16 hours call. Who does that? It's abnormal, not normal, data anomaly. Similarly, call overlap. One call has not been ended, another call started. So highly suspicious scenario. So this is also two scenarios, and then high call duration to specific destination, frequent calls to flag destination, quick and efficient for known patterns. I mean, these are some uh, features of rule based anomaly alerts, because clear clearly rules, if you know about the fraud patterns, as you are a subject matter expert and you are monitoring the fraud records. So rules, or these designing of data anomalies, that is condition based, is up to you, that how you want to code the data. As you know that fraud trends keep changing, so these monitoring conditions keep changing. But this is essential because it only gives the model, to learn and adapt these four patterns. So quickly, I will tell about AI-based dissection. Use the ANN model, artificial neural network, to analyze complex relationship data, identifies hidden pattern in evolving fraud strategy. These all points I have, also elaborated in previous projects. Enhances detection capabilities beyond predefined rules. As I told you in last project, also auto threshold final model was, it was finding hidden patterns. Like this, you can see here. Last time, this is the result. You can see France call in the last 900 minutes call duration. Destination fraud was disposed as destination fraud. So that in I told last time also that historical data was not having this much call duration. It was all having more than 1000 call duration. So this was a hidden pattern. Also, I will show you the example like this. You can see the Italy call, single call for 200 minutes. How much is the probability? 46%. But it is categorized as high risk destination. But it doesn't alert was not fired because the threshold was less. So high risk destination, single call record to Italy. Why? Because the 200 minutes you can see here, high risk destination, other another Guinea-Bissau, three calls, 280 minutes, 240 minutes, and this one 283 minutes qualified for the high risk destination. So this Italy call at 46 percent prediction, I mean for probability is still at radar. One more call to Italy, similar duration, the the probability will increase. And and similarly one more call, and then it qualify for the high risk destination. So this is something AIML models, they are very good at to finding the hidden patterns, because they can relate. So that's why this ML means machine is learning. And deep learning, when we talk about ANN network, artificial neural networks, machine is mimicking. Okay, so let's quickly end this slide. So these are the advantage these of this hybrid approach. Reduce false positives. Rules provide precision for known cases. Means rules are made on based on previous historical data of fraud, as we all know. So rule based alert means to flag the records which are similar to previous fraud records. So you must be asking that why are you making these data anomaly alerts rather than you can spool the records out from the clustering reports. But you can understand that as a subject matter expert, if you are a subject matter expert of fraud, then you know the specific behavior or characteristics of fraud. So you make rules based on value, count, duration, volume, etc. to target those fraud patterns which are known to you. So rules are based on clear and clear picture, and they are defined criteria and quick and accurate to flag suspicious activity. So we cannot rely on records to records of clustering reports, because we will analyze those clustering reports separately. We can give scoring to those to those clustering reports according to average call duration, and if the value of some clustering report is high rather than another, etc. But we know the rules are very much essential, because those rules are basically which I'm calling here data anomalies alerts. So this is the ideology that to give the AI agents the extreme suspicious records so that they can train on real life scenario. And again, something like that happen, then they will be in action and generate alerts plus system action on behalf of human analyst. So you can understand now that why we have chosen those data anomaly alerts to pass the records through them to the AI agents in the back. So next time the same scenario came, they are ready to take action. Okay, so let's move to next slide. Clustering reports using k-means clustering means unsupervised machine learning algorithm. And you can see now the workflow for a clustering report and AI agents. So this is the workflow, and I have very intelligently designed the data pipelines for automation and report and alert generation. So firstly, as you can see in the presentation window, file one will come, that is incoming call detail record. file. So then assigning weights means, weights will be assigned for k-means clustering. Higher weights will be given to the higher scenario for the cluster that we have chosen. So an auto threshold for clustering using Charlotte score. Charlotte score will decide how many clusters should be formed as per the Charlotte score. Then clustering report will be generated, and you can see here three clustering reports are there: overlap, which consists of overlapping calls, non-overlapping calls, and high duration reports. High duration means greater than 1000 minutes. I have given the threshold for these clusters, and non-overlap, I have grouped it through the call duration, means short duration, long duration, mid duration, mid level call duration. So as call duration similarity it will group, and overlap call I already told you. Before that, you can see here the intelligent part, the clustering report generation is here. So you can see here, as the same data is passed to clustering report generation, the same data has been passed to the condition based data anomaly alerts. So if the threshold has been breached, and I have used the same data science functionality of auto threshold of using quantile as a function. So we will be using top 2% or 1% as per our business problem. So these those records should qualify, and if they met, the data anomaly alerts will fire that, and the records which will be caught up in these alerts will be given AI agents to train upon. So now you can understand that instead of taking a record out of clustering report generation, we have placed the AI agents parallel to the processing of data. See, so the same data is coming to clustering reports, and the same data is coming to train AI agents if they qualify the data anomaly alerts. So it means the extreme scenarios conditions are there. So why? Because clustering reports are already have a high count of reports, and we have already customized it through different conditions, and even human analyst is sitting on there to check it. So thirdly, that if we place again these train agent after this clustering report generation, then latency will be there. Okay, and then yeah, we and because as I told you before, fraud rules are very straightforward to capture the trends. As a subject matter expert, if I give particular conditions, then only those conditions, if qualified, the call records will be passed to train AI agents to train upon. So that's why we have placed the agent for the parallel processing of data, the data of through the data which is going to clustering representation and is coming through data and anomaly alerts towards the AI agents to train upon. So let's go ahead. Then what happens? Then I have given the scenarios. Then second file will come. I mean incoming record file. Then again same k-mean clustering will be given weights, and auto threshold will be given by Charlotte score to generate how many clusters, and then clustering report will be generated. But this time what happened? If again the scenario will be breached, it means that is suspicious scenario. So AI agent will take in action, because we have trained AI agents on particular extreme scenarios which are called data anomaly. So AI agents will be in action. Okay, so quickly understand now, as you can see here on presentation screen, that this is something how the clustering reports will look like. You can see non-overlap clustering report. It has a timestamp also. So you can see here it is grouped by the minutes. So you can see similar minute: 251, 263, Albania, Bolivia, destination Latvia, 251, Australia, 263, Cuba, 251. So for non-overlapping only, group by the similar minutes calling, and for overlap you can see here uh, uh, overlap call is there. One call has not been ended, other started, and overlap identifier is there. Overlap means one means this is overlap call, and you can see here non-overlap means overlap identifier is zero, value is zero. Okay, so this is the simple representation I have made. I am customize the report for a simple representation. Then okay, what happens is this is hybrid approach, rule-based anomalies plus AI agents. I already told. Now you can see here data anomaly alerts will something look like this only. That high usage scenario I told you. And this, you can see this color number have greater than 786 minutes. This 78 6 minutes of threshold is being populated automatically. As we are taking, I will check in code what is the, we are taking top 2% of the fraud, probability, I mean threshold. Top 2% or 1% is the threshold of the, how much, top calls are there, top high duration calls. So you can see here, so Bulgaria Mobile is having one over greater than 1000 minutes. So successfully captured the scenario which we want to capture, that high duration calls. And another is overlapping. So I told you only two fraud scenarios we are capturing here. Greater high duration, high usage scenario, it means greater than calls, high duration calls. And data anomalies for second is overlapping call. So you can see here Latvia call, one call has not ended, another call started. You can see here Latvia call, same caller for same caller number. And 6-4, the call started and ended 10:27, but in between 10:24 another call started. So this was a very simple and explanation. And I have used data augmentation. What is data augmentation? Instead of synthetic data, because you can see the data anomaly alerts in my project, they're giving only 5 6 records, maximum, because data is very less. Okay, so we need data augmentation to increase the data. So why in need of data augmentation? It improves model generalization. As I told you, we need more data to train that model, because then they will only learn the to segregate. Reduces overfitting on limited data. Similarly, augmentation technique is add noise to correlation. And I will tell you, earlier model was having some problem, and new model I made some feature called average functions. So then it was able to understand the data. And I will tell you how these models understand the data. So key feature used is average call duration by caller and destination. Okay, so here we are in production code, and you can see, quickly we will see how intelligently the automation of data pipelines for workflow of clustering reports, plus anomaly alerts, plus AI and live alerts has been placed. So you can see it is a long code, and with high count of dedicated functions, and high count of data transformations, debugging, fine tuning, and model training, predictions, actions, alert and depot generation, etc. has been done. So let's start now. See from here, when incoming record file first is coming, so it is being taken from the SQL database. So I will show the output of debugging commands and printing commands as well. You can see here, firstly what happened, the file which is coming, incoming record file 1. Okay, so what happening is, file status report will be sent. So it will be very good for to know that file has been received, and the data has been is in process. So that file status, it is showing that it has been sent. When I will run this code in front of you, then something, this will be coming like this. Last time what happened is, in output window, this is the summary of that. So records to process, it will show that these are the 77 records to process. And then I told you that it will, the Charlotte score will start calculating the scores. And for the, or like overlap cluster will be the first, because we have given higher weights. So it is showing the optimal number of clusters based on the most common Charlotte score is this much. So overlap clustering report generated, report sent successfully firstly for this much color number, and then again report sent successfully, and then it's saying this for this color number overlap clustering report sent. Similarly for non overlap, it is showing 11 this much, and then the reports will be sent. Similarly for high duration clustering report as well. And you can see that immediately after that has been sent, as I told you. Let me show you the workflow. So you can see here, immediately after that clustering report generation, data anomaly alerts will take place. You can see here. Now the dynamic threshold for data anomaly alert is 786 minutes. This is being calculated by the auto threshold function. Let me show you again. So that's why I'm showing you into two windows simultaneously that what is happening. So you can see here after clustering report, here there will be a function of here you can see here print the dynamic threshold for data anomaly alert is this much, and it is calculated by this quantile function told you, that is using data science methodology. So 0.98, I told you now 1% or 2%. So we are taking 2% of the high duration calls. So that's why it has calculated and printed like this 786 minutes something. The threshold was automatically uh, populated. So that you can see alert sent successfully, alert will be sent, and then clean training data has been generated. See, six records are there starting from 0 till 5. So what happen is that data anomaly alerts, the clean data will be segregated from those alerts, and that then there is a repository, and means we have to save the record as well, na, to for we have to make a directory for a repository. So there is a directory for that. You can see here fraud data repository directory is there. So here in this excel file, the data will be saved from here. So that's why it is saying fraud data updated successfully, and that final fraud data is being printed also for understanding purpose. Then what happened is file status. Then second file will be processed as I told you here, incoming record second file. So that file will be processed here. Then again we got file status sent successfully, file report sent. Then again same process of clustering and average shallow test code will generate the overlap, non-overlap, and high duration cluster reports will be sent. And then what happens, you can see here now. So what we have done is the training data for the AI agents that has been processed before. Now the training start. So you can see here the combined training data is being made. Why? Because we both want non, no, not fraud and fraud calls. So you can see here fraud labels are there, in which one stands for fraud, zero stands for not fraud. So you can see here fraud label, not fraud cases are 71, fraud cases are 6. So combined rating data is being made because I told you we need both fraud records and not fraud records for AI agents to train upon. So similarly, you can see here fraud label 1 and 0 as well, and then for overlap as well. So two AI agent for frauds are there. One for fraud model, and another for overlap fraud model. One for this high duration, and another is overlap call. Then this is all about processing the data, and then training of data is taken place, and then fraud model performance and overlap model performance is there. Then you can see AI agent models will be saved, and and these are the features that being they have used. So I told you that I have added this feature extra average call duration to fine tune the model, because it was having some problem. Okay, so then I will tell you in the production when alerts will generate, I mean reports and alerts will generate. So quickly I will show you now uh, that what was the problem I faced and how I rectified it. So yeah, let me show you. Okay, so here we are in coding screen. So this is the previous code. You can see here after when the training data is combined and the training data is made, then we created some features like this only original destination, and then encoding, and then some duration time based encoding, and we are augmenting the data, means we are making the data not through synthetic data, means mode function, but using this. You can see here multiplier is equal to 20. So whatever the data is in DF is a data frame, you can make it 20 times. So some manual, as it is augmented data function. This is some manual changes we have done. So the thing is that it is only happens when you are subject matter expert. But you can see here after that there is no such function. I mean there is no feature engineering for model to learn. So model will learn itself. But here in new improved code, you can see here I have added this add average call duration same destination function. So it is grouping the records by caller number, original destination, and taking the average of call duration. Mean means average. So that's why this has more much efficiency. Let's see it through results. So uh, previous code, what it did, what it added the predictions and made make a data frame. See here, threshold is same in previous and new code as well. 0.99 quantile value means 100 minus 99 1%. We are taking top 1% of what, of probability for both models, fraud model and overlap model. C. Okay, and then we are saving the predictions into this. You can see here call CDR with alerts P for previous, and in new code we are saving to call CDR here. Call CDR with alerts underscore n means new. So previous and new. So in previous there was problem previous model. So this new n with n is our new model, fine tuned model. So let's see the difference. What we were having problem with. We have both data set p and new. So yeah, p is here. Let me show you. Okay, I will just expand a little bit and I will just zoom to understand more clearly. Okay, let me apply filter and let me, yeah, so it's clear now. You can see here if I take, this is our I column is fraud alert column, which have value of true or false. This is the value flagged by our fraud model, true and false, and this is overlap alert column, which have true or false value flagged by our overlap model. So this model is giving up to the mark result. See, if I click true for overlap model here, you can see here there are 6 records, but you can see here perfectly. I mean 2 records for each same color number, you can see, and number ending with 728, number ending 6666, and lastly number ending with 999. So 2 calls, one call has not started, other call in between, one call has not ended, the other call in between started. You can see here for 728 724 the call started, and 747 it ended in between. 738 call is started. So and with number ending with 6666 5 2 the call started. 531 call ended in between. 528 call started. Similarly 44426 in between. 424 started. So this is performing well. Why? Because all all the 6 records for three same color number has been identified, which is in overlap. So there is no issue. But when click the true for use fraud model, you can see here. Now I will show you and I will highlight with yellow which are the correct records identified, like Angola and Bulgaria mobile. So these are correct records. You can see true and true. Because we have given, we want output to be more than 1000 duration calls to be flagged as true. But why this? You can see here how much 6 calls have been wrongly identified. I will mark it as red for these. Okay, these duration, these minutes. You can see here all the duration is 241. Someone Latvia has Australian call has 260 minutes. It is been flagged as true. Australian call again has minutes 250 minutes true. So why this is something, as in data scientist, you have to understand that my model, why this is predicting. This is not the output that I am expecting. So you have to fine tune your model accordingly. So now I will tell, this is internally I am telling you that what these neural networks are capable of and how they configure, how they analyze the data. So what happens is in this code I told you, this is previous code results. So in this I have not given any feature engineering to add to the model. So model have himself model have itself analyzed the data and simply flagged these record as fraudulent records. For 6 record has been falsely identified as true. It should not be only 2 records for these Bulgaria and Angola call. One call is more than 1,000, another call is more than 4,000. This should be flagged as per my business requirement. So see, I will tell you how it works, how a model failed here. I will tell you. So basically, let me add a column to understand it. This is in front of you. I'm telling this is live. I mean, I have already made the formulas. So I will put here. Okay, so now I will drag it for each every one of the row. Okay, here. So what is it? I will call it as sum of duration. Okay, so what model did? For whole data set, it has taken the total sum of duration as per destination for Cuba, Somalia, Angola, and every destination else. But you will be asking why it we have taken minutes, because at that time in Python code it is called duration, but called duration is just the transformation of minute into seconds. So for better presentation, we I am taking minute column so that you can have a broader idea. Okay, so now this has been made by the model itself to understand the data. I mean, these neural networks, they are very good in finding similar patterns. So they have internally done that, and then model, and I will just put a filter, and we will just have the fraud records which are records which are flagged as true. Okay, so these are the records we have to analyze why these has been wrongly identified. So let's take an example of Australia only. Okay, now I will clear the filter and I will just see the check. I mean, just put the Australian calls. So yeah, this is the whole Australian calls in the whole dataset that has been processed at once. So you can see here, this has been flagged. This has been flagged as true. So okay, so no problem. Okay, no problem. And I mean, there should be any much count of calls from any country. Okay, so but we have to identify why these two calls are flagged as true only. So you can see here when what model does, when because I have not given any feature engineering to the model. So model, I told you that made this column, it total sum of duration as per destination. So see here now, when model checks, this is Australian call in Australia. You can see here this call is having 260 minutes, the highest duration in the minutes column. Okay, so it's gives an idea that it is the highest duration call in the minute column. Then it goes for this column, sum of duration per destination. Then it also check that it is the having this much 1099. I mean, all having same values, but it makes it is a record contender for the fraud call because both values are high, even though you can see that 1099 value is same. Why same? Because it is summing up the duration for Australian calls, so it should be same. But because of 260 minutes and the same value here makes it the first contender. Then you can see here similarly 250 call minutes of call got qualified because it is a second high volume call as per duration, and then as per minutes, and then again as per sum of duration column. So it has put that. Similarly, you can see that if I take one more example of which will calls were there, I believe Albania. See why you were saying this call from Albania calls got flagged as fraud. Why? Because you can see here in minutes column, 240 minutes is the highest duration call. according to minutes, and then again sum of duration column 757. So that's why, without feature engineering, it understand the data itself, and had made the decision that because two columns are made, and in both columns the call this is of call duration is extremely high. So that's why it has flagged the top calls. Like in Albania, it was not able to find any other call related to 240 minutes call. So in this column, minutes column, and again in some more duration column, the value is high, flag it. Similarly, if we go back to Australia, see, check now, 260, 250. Here also some of duration high, flag it. And there is no such call which is nearby to it. So model understand the data itself and making decision. And let's go to Angola call. Oh, sorry, Angola is yeah, Angola. So you can see here now Angola have this much of calls, but this qualified as true, flagged. And why? Because you can see here another another values in minutes column are very low, 61, 29, 59, and 41055 here, and 4381 here. So this call, got recognized as fraud call because it got the higher stats, top calls according to two columns and the values. Similarly, Bulgaria mobile, which is correctly identified, I believe this one. See, this is the only single call, so it has to qualify because both columns have the similar figure. And also, if I show one more example to you, last example, I believe Latvia premium rate was there. See here. It is also flagged of 241 calls. Why? Because this is a single call for Latvia premium rate and no other calls. So 241 minutes and sum of duration of 241 minutes qualified, because no other calls, no other calls to make the differences. So this is not we want. This is not our business requirement. We need the training records of we gave of 1,000 minute or 4,000 minute call, that should only qualify. So we will do feature engineering, and I will show you that with a simple feature engineering how the things change. Okay. Okay, so let's add one more column here. I will just uh, same function, average color, average called yeah, you can say average minutes per color for destination. Okay, I will just put that formula I have already made, and we will see what happens. Okay. So yeah, so because this is this data set is made by me, so this is very small data set, and model has because in real time it has many much columns, so model can itself make idea. You can see that neural networks are best, and so that's why, because the features are very less, that's why model fails here. But when I gave some another feature, a single feature, you can see the model will understand better. So just this column I have added. Now, if I go and see, the case is flagged as true. Now, what it does, it will compare both these three columns: minutes column, sum of duration column that made by the model itself, and also the average minutes. So it will have an idea now that minutes are same, highest for Angola call. The sum of duration is also highest for Angola call among the other Angola calls, and then this average minutes per caller per destination is also similar. I mean higher for Angola call, flag it. Similarly, Bulgaria was single call, so it will flag itself. It will flag without any doubt, because you can see here now three columns are producing the very high values. Now, but when it comes to another calls, let's take an example of Australia. Okay, let's go to Australian calls now. I will take the Australian calls. Okay, and for understanding purpose, I will select that Bulgaria mobile call. Okay, and see now that now model has three column to compare: minutes column, sum of duration column, and average minute per caller per destination column. So it understands now that this is the average column, because according to values, model calculates in an instant time that this is the average column per caller per destination. So now I have to compare the values. So the actual fraud records where we have given 1000, and one call was 5000 minutes in training records. Now it understands that all three columns should have the similar values, and see here Australian column for this last time flagged as true. Now there is variation: 260, 1099, 260, then 250, 1099, 50, and it finds that this pattern was having the top call among the destination, but also the values are very similar. I mean, identical here in this new record, but in training record also it will find this, because this column will, this is column I have added in this new data set now, but in training data set this will be added. So the model will judge that now these three columns have to be similar. See, now go for Albania also. So why it flagged as Australia last time? Because there was no average column, and there was no feature engineering, and no average column of per color per destination was there. So that's why I told they are very good in finding in emerging new patterns. So it treated as a new pattern without feature engineering, and it has given the higher probability. Now what happens? Now the fraud probability for these false positive cases will fall little bit, and that will make us help us, because we are taking high fraud probabilities. So it will not come. Now we will see for Angola. Oh, sorry, Albania. Yeah, last time this call flagged as true for Albania. Now see, again take the example of Bulgaria 1250 12550. When it is now analyzing, it can see that 240 minutes in minutes column, 756 in sum of duration column, 240 minutes in average minute column, but it is not same. But for record that I have training data, the value should be similar. The average column should be similar also, and it should be higher among another calls to the same destination. So it will judge now that I have to fall the probabilities for other calls rather than these fraud calls. And even I will show you that what are the calls that training records we have given. Okay, so here we are, and this is the fraud data repository. I mean the directory in which these fraud records are being saved every time. So remember, this AI agent thing is on real time. They are getting trained, and then they will take action. So this is these are the calls. You can see beside this, these are for overlap calls because they are similar number. Okay. Check these number: Angola, Bulgaria, 5160 minutes, 1353 minutes. So initially, only these six records were given, and we have applied that data augmentation to multiply 20 times, and added not for record as well. So these two training records for high duration calls, these are the data anomaly alerts. The records through data anomaly alerts have been passed, that will be passed to AI agents. So the business requirement is, other than overlap call, these calls, high duration calls, should be flagged, like more than 1000, more than 5000. So that's why now it will compare. Now you understand now that when it compare, that Bulgaria qualifies. Why? Bulgaria have three columns to compare, and three values. Even the average value is very high and similar to the minute column and sum of duration column. And also the fraud records that I am being trained upon, the model will say that it is also for Bulgaria mobile, and it is one more than 1000. So now it will be able to find efficiently the fraud records, and the false positive will be gone. It will, the false positive will gone like a wind. So now you understand how these things happens. And if now I will show you the even the that one. I mean the data set calculation with the new code. So what happens? I have already saved. It is already saved because it is being you know ran last time. So the results are being saved. See here, if I put a filter and if I check the true value for the fraud alert column, see now gone. No, wait a second. Now yeah, I will clear this. This is the previous model results and new model results. We will compare. See now, only these six was the false positive. Now with the only one feature engineering, when we have mitigate the false positive. See, Angola, Bulgaria is now being only captured as true, all other are as false. See, I'm not making this up. See, true, okay, Angola, Bulgaria. And you will ask now what happened to those calls. Though for those calls, model has fallen the probabilities. So if you ask about this Australian call of 260 minutes, let's check. We'll just put it here. I will select OKC. Fraud alert false. What a beauty. Fraud probability 98.88. See, last time what was it? Similarly, the probability was this one 99.55, and from 99.55 98.88. So something less than it is I mean less than 1%, but it has fallen because the probability for us to now uh, uh, specify the record as true is 99.99 something. Because if I clear the filter now and see what is the probability, 99.99, 99.99. See, so only one feature engineering they have fallen the probabilities. So see, if I add something more, like some more feature like average caller per destination, this was combined. So average caller per destination, then average caller sorry, average call duration per caller, and this will also average call per destination, then call count per caller, call count per destination. So similarly, I will keep adding the this features, and the probability will keep falling. And this is how this works. This is called data science, and this is called feature engineering. So the model will have more features for you to to analyze, and then the model will understand, and then model will judge better. So I will tell you that the main thing I always tell you all every time that the main aim is to make your model efficient. So just adding one feature, we have fine tuned the results, and results turned into our favor when only those two calls which we want has been recognized and are being flagged as fraud calls. So that's that's how we can fine tune our model, and then the business requirements can be met. So let's move to next part. Okay, so before going to the coding screen, just I want to show you that I already have told elaborated. I mean that uh, what was model seeing before, some raw picture for you, stats. I mean through this chart. Call duration is same minutes column conversion to seconds. So before that, when call duration as per destination wise was looking like this, small bars, medium bars, big bar, and then when we introduce the feature average call duration, same per color per per destination, then this one you can see here how clear the picture is. This, you know 3 lakh minutes something nearby is, our Angola call. This is Bulgaria mobile call. So, these are another calls for another destination. But this, model was able to find the relation. You can see here the bar are similar. You can see Bulgaria and Angola. So, okay, then another stat is like this only. The old model, what it was doing, it was giving six false positives as I showed you. So error rate about 75% something like this. You can see count of false positives. And when new model is introduced, there is no false positive. So yeah, the error rate becomes 0.00. Now let's go to the coding part. So see, uh, okay, okay. So yeah, let's further not waste time, and I will just run this code now. Okay, so the code has started running. Now you can see here, and similarly, the clustering reports will happen, come, and then the other aligned process will take. So I will show the email window is clean. So yeah, file status report send. Okay, okay, start processing. Wow, 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 wow. Let's analyze both windows. So see, firstly it is showing file process has been file has been received and it has been reported as well for in processing. Then Charlotte score. You see the cluster firstly overlap. Two clusters have been made according to the Charlotte score. Then for non-overlap, there is 11 clusters, and the report are immediately sending. See, wow, what a beauty! File process report, status report, mail overlap clustering report. See, similarly, and code is running. Similarly, we are getting reports, and other process is in line or is on line. So see, no wallet cluster found for high duration record. Wow, what a beauty! Generated single report because cluster has not been found, and then the report sent successfully for the high duration cluster as well. Then you can dynamic threshold for data anomaly alert. I told you top 2% of the call duration. So 78 above call 7 86 minutes gone for data anomaly alerts. Okay, fraud data updated successfully as I told you for that fraud repository. For data is updated successfully. That has been placed there in that directory. So the optimal number of clusters again. First part is done. Second file is see F2 file processed at this much. Second file has come. Now what will happen? The data you can see here data anomaly alerts. Now if something again this scenario high usage scenario and overlapping call scenario happen, we will analyze in detail also. Then the AI agent will take action. So second file is processed, and then first is overlap, then non-overlap, and then high duration. And similarly, we go to the coding screen. We are seeing the output as well. I mean, I put in the debugging printing command. See non-overlap clustering reports and cluster for cluster 12 also reports and successfully now. So for no valid cluster found for high duration record, see generating a single report generated. Then training data has been generated and class distribution and all. That was all very intelligently data pipeline design. See all the stats are there. Fraud model training data, then overlap model training data. These are the stats. AI agent model have been saved, and you can see here these are the features for AI overlap agent model, fraud agent model for AI. Then what happened is in a split second it is happening. You can see alert generated. This is the same data set made predictions. Then processing record one fraud probability this much, this much, this much, and then alert generated for this much. See. I think I have to go to email window now. You can see here. Wow, what a beauty! AI agent live fraud alert. Now we will analyze, and you can see here analyze from the first thing. First, let's end that. See the code has stopped now because every alert has been sent successfully. And see, I told you that we have already mitigated that false positive cases. then we don't have here those, because then I have to put something, extra conditional command that, but as it is fully automated, so no false positive, so no, I have to don't have to give any manual condition that, to ignore those false positive alerts. So that's what should the model, that should be the system model, and system should be like that only. Correct cases, because we have make the model efficient. Now we will analyze. See, firstly I told you, okay, see the incoming CDR file 1. So here, file processed F1, file processed at this time. See, I have put the timestamp also. And if I open this, this is giving the status. Dear user, this is file status report that call records are received and are in state of further processing. Below are the first five sample records from the received data. So you know that, this app support team does, but here I am everything. I am the developer, I am the data scientist, I am the app support, I am the debugger, I am the tester, and now, so this should be come in mind that, file has been processed, so we should have alert like that, that the file has been received, and the, in their process records are in process states. So then I told you, overlap clustering report, we have given higher weights, so it will be generated first. Dear user, this is overlap clustering report for color number this beauty. See, so human analyst is sitting over there and analyzing that, this overlap clustering report has been received, and this is suspicious report, and I have one call has not ended. So you can see here 6:4, the call started 10:27, the call ended, but in between 10:24 the another call started for the same caller number to the destination Latvia. So perfectly reported by overlapping clustering report. Second, overlapping custody report for this caller. So I have not clubbed the, caller number into single report inside it, because data is very less. So for presentation purpose, it is very easy and simple for you all to understand. So overlap clustering report for caller number this is a timestamp, and this the time the caller number has called to Benin, and then, 5:24 in the evening the call started, 5:48 it ended, but before that 5:38 in between the call started, and overlap identifier is there, which is saying that one is the value, that it means it is a overlap call. So, first file processed, so we have our clustering reports in line to be generated. So human analyst is watching all this, and then non overlap clustering report, which don't have, overlap calls, but still I told you, I gave customize it according to the call, similar call, caller minutes. So you can see here similar call minutes, 100, all similar. So you can understand that we can design it anyhow, and any way will be like. So even we can take the average call duration of cluster, so give the scoring also through that, which average, which cluster is having more average call duration than others. So you can like, call count also, value also for the calls, so you can design it as per your business requirements. So we will see one two or more sample of this, like this report 9. So see, Albania, Australia, Anguilla, mobile, similar calls, 90, 90, 89, 87, 91 minutes, 86 minutes. So it will group, because I have customized it same way. So if I go for this, you can say where Australia, Albania, 72, 97, 72. So whatever it find in similar, according to data set, it will club it in single same cluster. So we have overlap cluster, because that is suspicious activity, and non-overlap we have clubbed it, we grouped it through minutes, so that, we can have a, clear picture. Then high duration report. So you see what a beauty. I told you, when high duration is there, and we have trained the human analyst that overlap and high duration are, clustering reports are very high priority. So it will just check the that I have checked the overlap, and now I will check the high duration. So let's open. See, Angola and Momaria. See, the scenario is like that only, that human analyst is sitting, and suddenly he sees this, that Angola and Bulgaria is captured, and the call, duration minutes are 1,000 and 5,000. So this is a suspicious scenario, very. So what it has to, give the, these justify the, I mean, it has to. report these calls, that whether it is genuine usage or to client and customer, that we have the fraud event has been reported, and we are we need to confirm it with you. So similarly, what happened is, uh, through the same data I told you, let's go to the PPT. Same data, clustering report generation, same data we pass to data anomaly alert, parallel data processing. See what happened now is, what a beautiful this all intelligently designed this process. So we have this call Angola of 5,000 minutes something, Bulgaria of 1,000 minutes something, and what happened is, you can see here, data anomaly alert. Anomaly has been found, and what is abnormal call? What is the call which is other than others, not a normal pattern. So see, Bulgaria, same 1000 minute call, data anomaly alert, high usage scenario. Dear user, this is high usage alert for caller number this with call duration greater than 786 minutes, and this 78 minutes is auto threshold. I mean, we have put the function of highest 2% of top calls. So for high duration, these two calls are very high. They are being detected by our auto threshold feature, and then Angola is also been caught. They see 15160. So both the calls, the Angola of 5,000 minutes and sorry, Bulgaria of 1,000 minutes are caught in data anomaly alert, and same was coming here, like 1000 Bulgaria, Angola, same calls, same caller number. So analyst knows now what happens for human analyst now, that it understand now that my management has put the data anomaly alerts for me to alert. And then I checked this report, high duration, it was having high duration. So instantly he's thinking, and second alarm, that no, this is this become highly suspicious now, because data anomaly alert fired for the same records, for same color number of 728 and 1254 here. 728, you can see here, 728 and 154. Now data anomaly alert has been fired. So now I have to definitely report this of fraud incident, the client or customer, whatever the SOP or SUW they have made. So similarly, just see overlap clustering report, starting with 666 and 777, just that we saw in clustering report, 666, 777. Now data anomaly alerts had caught that 666. See, this overlapping call alert for this call number, same, and this for 777 as well. See, wow, what a beauty! Wow, what a beauty! See how intelligently this whole process, data pipelines, you can see is designed, so that now human analysts don't have to do much now, because we have already done so much automation. Okay, so at least just you have to report that, and then what happens? File is processed. Similarly, file records are coming from anywhere. Then second file comes. You can see here, second file processed. Your user, this is file state report for the and timestamp is also there. Call records are received are in state of further processing. Below are the first five sample records. But you can see here the sample records are there, but some bug is also there. You can see unwanted column is there. So as a I have placed this because we should also know that how data is coming. We have to rectify this issue, and we will rectify this issue. I have already put that in data pipeline. I have already rectified this issue. This will not affect our predictions and output of these clustering and AI agent alerts. So now understand, now this file has been processed. So similarly, the overlap clustering report will generate. It has generated for this number ending 6666 for Angola. You can see here the call started at 52 until 531. In between 528, the another call started for same number, and similarly for the this number. So this time we have three overlap clustering report. It means three overlap caller are there. Okay. So similarly, non-overlapping call, I have already shown you that it will group according to minutes, and we will customize it as per our business requirement. So another non-overlap call. So similar minutes clubbed in and under non-overlap, because they don't have an overlap calls. High duration. So see, another alarming. When a human analyst now knows that file 2 has been processed, and again overlapping custody report has generated the overlap calls. So now I have to check and report. And before that, it comes to know that high duration clustering report is also there, and the call is again, see, 4,000 minute to Angola and 1,000 mingle to Bulgaria in the moment. Now, what happened last time? He manually did that and sent a mail. And we can also automate the SMS also for the client and customer. We can also automate the email for customer and client also, that fraud incident has been reported. Similarly, third, our human analysis, uh, you know uh, taking a feedback loop, for feedback loop it is reporting and then confirming with the customer and client. And what happens now, when second time this happens, means some fraudster are deliberately doing it, then again this happens. I told you, like, AI agents are sitting there and they are in action. Firstly, happens data anomaly alerts, because I told you that rule based data anomaly alerts are straightforward. So we have put in that and they have generated that alerts, and those records has been given to AI agents to train upon. See, now this time again I told you clustering report will generate, AI agents will be in action. So see here, what a beauty. You will be impressed. That, see, now compare overlap call fraud, AI agent P1 priority 1, live fraud alert, overlap call fraud probability 99.99%. For which number? 4728. And what is that number? That is the number that comes here. Overlapping clustering report for caller 4728. The it has recognized AI agent, and what it has done, see, P1 AI agent live fraud alert, overlap call fraud for this number, fraud probability this much is a timestamp. Dear user, this is fraud alert for caller number this with high probability of fraud. And the same records are there. AI based decision disposition for this alert is fraud destination Cuba, Angola. See, Cuba, Angola has been recognized, temporarily barred for this caller number. So the action has been taken as soon as human analysts, before the human analyst, AI agents have caught these records, taken the action, and generated the alerts. So you can see parallelly, you can see the time frame difference. You can see, that's why I put these timestamps. File 2, where is file 2? 16/5/44. The file was processed, and then clustering report generated between 16/5. You can see here, what is the time? 16/6. See, within 2 minutes time, 16/6/57, and file process was 16/5/44. See, 16/5 and this much. Sorry, uh, what was the overlap call number? Let's compare that also. You will tell that, because I am not making this up. So yeah, here. Okay. 16/5 clustering report generated also for number 6666. 16/5/48. 16/5/48, and this is the number 16/7/04. See, within 2 minutes, action has been taken. Same AI agent live fraud alert, overlap call fraud. Dear user, this is fraud alert for caller. This with high probability of fraud. Is AI based disposition of fraud alert is fraud. Destination Angola, temporarily barred for this caller number. See. So a human analyst, have simply have to confirm these call records that the fraud incident has been reported, sir. Madam, I'm calling from this fraud vendor, and I want to confirm from you. So now we will compare the even the you can see high usage report as well. See, high duration clustering report, Angola, Bulgaria. Okay, and here destination trigger fraud. Bulgaria. Wow, what a beauty. This is a fraud alert for this destination Bulgaria. Temporarily barred for this caller number. Sorry. Similarly, for Angola as well, temporarily barred. So I want to show you that this whole process was intelligently designed by me, and this is my creation. And even you can see here, after you can see here now. When AI agent models have been saved, I have put a command also to check, caller found for already generated alerts, removing these from incoming data, matching caller this one. So this caller was already, I put a file, and for only for demonstration purpose we can do this. Fraud vendor has to do this, when data is coming from different sources. Like, sometimes we need near real time data exchange, some data warehouse, send those data records at real time. Those are not built. So so if AI agents have already generated that, and the all the entities are same, like you can see here below: caller number, destination, minute, call time, call and time. Then we can skip that alert, because it will falsely make duplicate alerts if it is already processed last time also, some way somehow, and it came again. So this there, and I mean, there are many scenarios that you have to consider. So that's why I was telling you, this whole code and code pipeline and data pipeline are very intelligent designed by me. And it didn't took us, it took ample time to design all this. This is not a work for a single day, single week. It took several weeks to make this. So similarly, we have fine-tuned the model, we have put the agents, and we have make the false positives negligible, and we were able to capture the fraud through AI agents and through data anomaly alerts. And we have you know synchronize the process so beautifully that minimum human efforts are needed. So now Akhil Singh Rawat is signing off, and I thank you for all of your support and love. Okay, bye bye now.